Hi guys, welcome to the session. This is Rashekar from St. Peter's Engineering College. Today we're going to discuss about the apriori algorithm. It is one of the important algorithm in the frequent relational frequent patterns. The apriori algorithm is a seminal algorithm proposed by the R. Agarwal and R. Srikanth in 1994 for mining frequent items for the Boolean association rules. These a priori algorithm is one of the best and one of the important algorithm in the data mining. The name of the algorithm is based on the fact that the algorithm uses the prior knowledge of the frequent items properties. These prior knowledge of the frequent item properties are the using in the algorithm techniques, which are the two major contents in the algorithms in the a priori algorithm is one is a two-step process. These two-step process will have a join and prune actions. The a priori employs an iterative approach known as a level-wise searches, where the k item sets are used within a k plus 1 item sets. For example, you have a 10 item sets are available in our database. The each and every data set will be compared with the n number of items are available in that particular level-wise searches. First, the set of the frequent items is found on the scanning of the database to accumulate the count of the each item and collecting those items from the satisfying the minimum support of the values. For example, the resulting set is denoted with an L1, and the next L1 is used to find the L2, and the set of the frequent two items will be used to find the L3. Like this L1, L2, L3, where the items are searched with an A. So in the L1 to L3 and L3 to L4, like this, if you what are the set of the result found on the L1, it will be moved to the next L2. Whatever the set of the result will be found on the L2, it will move to the search of the L3. Like this, the level of the frequent items will be moving from the one to the another one until no more frequent items will be found. That means no more K item sets can be found. To find the each L, K requires one full scan of the database. For example, if your scan of the day, if your database have an 10 items with an 10 different number of accounts, so each and every item will be scanned until there is no item sets, there is no item sets will be scanned of that particular data values. And this in this scanning process, we are removing the less count of the values from this searching process. Now let us start with a two-step process is followed with the a priori consisting algorithm with a join and pruning actions. This is the data set we are taking for an example with an a 10 IDs, that is a T 100, 200, 300, 400, 500, 600 and 700, 800, 900. These are all the item sets and the list of items with an IDs will be their count. For example, T100 will have a three list of items, that is I1, I2, I5. T200 will have a two list of items, that is I2, I4. T300 will have a two list of items, that is I3, I2 and I3. So here we have a minimum support of the 50% will be there, and the minimum confidence value is also 50% we have to maintain. If the item sets, if the item set will have a below 50% of the support, if you have to, if your item set don't have the 50% below, then remove that particular item set and you have to move to the next search. If your item set has a minimum confidence of the 50%, then keep that item set, and if there is minimum of that below of the confidence level of the 50%, you have to remove that one. We have a formula based that one is a confidence A implies B is equal to, that is a P by A is equal to support count of the A union B and the support count of the A. So for the support count is a minimum percentage is there, a 50% within an association rules. Now let's move to the example. First, guys, please note of the all the item sets available. That is a T100 to the T1 and I1, I2, I5. And for the clear informations, we'll follow the textbook here. This is the transactional data for all the electronics, that is a TID is equal to T100 to T900 and the list of items. The first search, here you have to observe that how many list of items are there. For example, I1, I2, next one is the I3, next one is the I4, I5. Is there any list of items above the I5? That means not rather than the I1, I2, I3, I4, I5. There is no other list of items are available in that particular data set. So the what are the list of items are there? Item sets are there. We have the first scan. In this first scan, the list of items are the I1, I2, I3, I4, I5. Now go to the database and check how many I1s are there, how many I2s are there, how many I3s, how many I4s, and how many I5s. Here see, in the T100 we have one I1, 2, 3, 4, 5, 6. So in our database, how many I1s are there? 6 I1s. Now check that how many I2s are there in the data set. 1, 2, 3, 4, 5, 6, 7. So we have a 7 I2s. Like this, we have to count all the how many item sets, what is how many I1s count, and how many I2s count, how many I3s count, how many I4s count, and how many I5s are the count. Now, after scanning the D values, that is represented with an C1, next go to the L set, that is a compare the candidate support count with a minimum support count. Here we have a 50%, we have to maintain the 50%. So remove the low count, low support count, less support count. Here we have an only less support count is I4 and I5. So is there any less support count which is a 0 or 1? So we don't have any zeros and 1. So we are moving into the next level, that is L1. So the same as it is, what are the list of items you have got, it will be displayed in the L1. Now we have to move the next search value, that is L2. To go to the L2, you have to scan again with these L1 items. So scan the L1 items. Now go to the I1, I2 is in a one pair, I1, I3 is a second pair, I1, I4 is a third pair, next I1, I5 is the fifth pair. So like this, you have to write down generate the new candidate list from the L1. That is a generate C2 candidates from L1. So you have to generate the new candidate list from the L1. Next one is the I2, I3 one pair, I2, I4 is the other pair, I2, I5 is the other pair. Next go to the I3, I4 is the next pair, I3, I5. The next one is I4, I5 is the pairs. Now these are all the items that you generated from the L1, that is a previous scan. Go to the data set again, database again, check how many I1, I2s are there in the list of items. Here, how many I1, I2s? I1, I2 within a single item set is a 1, 2, 3, 4. So 4 is the count of the I1, I2. Now check how many I1, I3s are there in the data set. I1, I3 1, I1, I3 2, I1, I3 3, I1, I3 4. Like this, you check, you scan all the data sets. What is the count? You write down all the counts here with a new generated item list. That is I1, I2s are 4 count, I1, I3 4, I1, I4 1, I1, I5 2, I2, I3 4. Like this, you have to write down all the count of the scan, count of the values from the data set. Now compare the candidate support count with the minimum support count. So what is the minimum support count we got? That is a below 2 is the minimum support count. So 2 is the minimum support count. If you want to remove the values, those are the zeros and 1 values. Here how many 1 values are there? I1, iPhone have a support count is 1, and I3, I4 support count is 0, I3, I5 support count is 1, I4, I5 support count is 0. So remove the values which support count is below 2. So remove that values and generate the new L2 item set. That is I1, I2 is 4, I1, I3 is 4, I1, I5 is 2, I2, I3 is 4, I2, I4 is 2, I2, I5 is 2. So we are removing the support count minimum 1 value from the generated list. So we got the L2 is the new generated list of the values. Now we have to generate the C3 candidate item set from L2. Why? Because L2 is the latest item set what we received from the database. Go to the same from the data set. The next one is I1, I2, I3 is the first set. I2, I1, I3, I5 is the second set. Why? Because if you verify the previous, if you verify the data set, here we have only two options, that is which have any three item sets are available. That is I1, I2, I5, I1, I2, I4, I1, I2, I3, I5, and I1, I2, I3. So you can easily, with a clear information, we have to find only two data item sets which will be generated with an L2. One is I1, I2, I5, and I1, I2, I3. So generate the new item set, generate the new item set from L2, that is a generate C3 candidates from L2. That is one is I1, I2, I3, and I1, I2, I5. Scan the same data set from the database and write on the count. How many I1, I2, I3s are there? I1, I2, I3, 1. I1, I2, I3 is the 2. We don't have any other item sets available with this combination. So the count is 2. The next count is I1, I2, I5. Search with the same item set. How many are available? I1, I2, I5, 1. I1, I2, I5, 2. So the support count is 2 only. Now compare the candidate support count with a minimum support count. We have the minimum support count is below 2. That means these two valid item sets are the perfectly item sets available with an L3. So we don't have another option with the next item set search. Why? Because in our database we have only these categories. And next search is I1, I2, I3, I5. So we can't move. That is why? Because that search count is only 1. Our minimum support count is 2. So we are not moving into the next level. So we are closing these comparisons here only. And this is the generation of the candidate item set within a frequent item set where the minimum support count is 2. So what is the final item set count we got is L3. That L3 item sets are I1, I2, I3, and I1, I2, I5. So here the detailed transaction is given by the pruning. Let's see here. Join I3 within a C3 generations with the L2 and L2 is an I1, I2. The comparisons values will be given here from here to here. When coming to the final item set, that is a prune value. The second item set is I1, I2, I3, I1, I2, which is refers here. I1, I3 is here. I1, I2. All the two subsets will give a same C3 values. Therefore, the final C3 value is I1, I2, I3 is the first one. I1, I2, I5 after the pruning values. So the final generation of the pruning candidates with the candidate 3 item sets are C3 from L2 using the a priori property. The final transaction result what we got is within a 2 item set, within a 2 item sets, that is I1, I2, I3 and I1, I2, I5 within a supporting count of 2. So this is the basic example of the This is a basic example of the pruning. This is the basic example of the a priori algorithm. A priori algorithm. Thank you.